In the past, conventional heat pump systems were known for their poor efficiency and performance in cold weather temperatures, but that was then. This is today. Mitsubishi Electric Cooling and Heating's revolutionary heat pump technology and our zoned comfort solutions can give everyone in your home total personalized comfort year-round, even in sub-zero temperatures. Here's how they work. Mitsubishi Electric's ultra-efficient heat pump systems consist of an indoor air handling unit and an outdoor condensing unit, which are connected via 2 refrigerant lines. Together, they work to efficiently transfer the desired cooling or heating energy to your personalized comfort zones. In summer, air conditioning is produced when heat energy from inside your home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed, and the system extracts heat from the outdoor air and transfers it inside to heat your home. For those requiring high-performance heating in colder temperatures and climates, our expert engineers have developed hyperheating inverter technology. Our hyperheating outdoor units use an enhanced compressor design to continue extracting heat energy, even when the true outdoor temperature reaches down to -13 degrees Fahrenheit. When compared to other fossil fuel burning heating systems, our modern heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option for your home. All of this is possible due to our advanced variable speed inverter compressor technology, which results in our systems using up to 40% less energy than conventional systems. In addition, a single outdoor unit can control up to 8 indoor units for added comfort and efficiency, with multiple styles available for added versatility. Our indoor units also feature true air filtration for your home, resulting in improved air quality with whisper quiet operation, perfect for any home, even a baby's nursery. With Mitsubishi Electric zoned comfort solutions, room-by-room temperature control is at your fingertips. With temperature sensed at each of the indoor units, constant comfort is now a reality. With Mitsubishi Electric zoned comfort solutions, put your comfort in constant cruise control. Our industry-leading, variable speed, inverter-driven compressor steadily provides precise cooling and heating in each room or zone. Stop guzzling gas with yesterday's technology. Inside, many attractive and discreet indoor unit styles are available. These include wall-mounted, floor-mounted, ceiling recessed, and ducted options. Our advanced filtration is constantly cleaning the air directly in each room or zone. With removable, cleanable filters, a healthier home is within your reach. Clear up the air and make comfort personal.
Everyone, I'm Lisa White. I'm with the Passive House Institute US. I'm going to be talking to you guys about the PHIUS Source Zero certification. Sam already laid a decent amount of groundwork, showing that PHIUS is kind of next in that stepping stool. Okay, so getting into this. Oh, there's a bit of a lag here. Okay, so I'm going to talk mostly about the PHIUS Plus standard, knowing that PHIUS Source Zero is built upon the PHIUS Plus standard. So the PHIUS Plus standard is a performance-based passive building standard with prescriptive requirements. So a lot of that Sam talked about, the moisture control, the indoor air quality, assuring the comfort, things that don't show up in the energy model. These are still really critical to a quality building. So we built prescriptive requirements, but we also have performance-based requirements in energy modeling that's required in certain targets to hit, which I'll show you. The PHIUS Source Zero certification then is, again, built on PHIUS Plus, but it's a conservation-first approach or design methodology for a net zero building with quality assurance throughout design and construction. So it is the certification goes through design process all the way through the end of construction with testing on site and design review. Okay, so the main certification requirements for PHIUS Plus are these 4 you see listed here. In the top red box, those are the same for all levels of PHIUS, whether it's a core program 2018 or Source Zero. These are all the same, and then the source energy target, or the net source energy target, is all that varies between the different programs. So I'm going to go ahead and talk about these kind of core requirements or core principles, and then we'll talk about the net source energy target differentiation at the end. I mentioned that the PHIUS Source Zero is a conservation-first approach to net zero, in a way that the conservation really favors passive building techniques or or conservation measures that influence heating and cooling loads specifically. So the way we kind of went about that is to set different space conditioning targets. That's for both annual energy and peak loads. Next, there's also a limit for air tightness. I'll get into that, but basically it was set based on building durability limitations. So our technical committee did research and decided this was an acceptable limit for building durability or long-term. So Sam was talking about the 100-year enclosure, a very airtight enclosure, if built right and moisture is managed correctly, can last a very long time. The third thing is the on-site quality assurance, testing and inspection. That is all of the programs that are built into this, nationally recognized programs, such as Zero Energy Ready Home, Energy Star, EPA Indoor Air Plus, and all of that. Blower door testing is required. That is all of the third-party quality assurance on-site testing that's built in to assure you're actually getting what you've designed. And then lastly, again, there's the net source energy target. Net source, we use source energy as a proxy for carbon. And I guess we've chosen to keep it in source energy rather than carbon because it still penalizes nuclear energy. So nuclear energy is just considered grid energy and is kind of given the same score or same source energy factor as coal or natural gas fired plant. And then the target itself or the result itself can be offset with different renewable energy, which I will talk about. Okay, so for the space conditioning targets, we look at annual demands and peak loads. So an annual demand is the amount of space conditioning energy that the equipment must deliver to the space. So a space needs a certain amount of heat for the year, a certain amount of cooling. It's not influenced by the equipment that's delivering it, it's just the amount of heat that must be delivered to the space or the amount of cooling. So meeting that annual demand target cannot be influenced by getting a better heat pump or getting a more efficient furnace or something. That's something that's very inherent to the passive design strategies, more insulation, air tightness, better windows, and all that. The peak loads that you must meet is the worst case condition. I think people are familiar with this. This size of the mechanical system, but also kind of ensures comfort. So we require that you meet all 4 of these targets. There's annual targets for heating and cooling, and then peak targets for heating and cooling. And the reason is that lower annual demands save energy and therefore operating costs, make it less expensive for the tenant. And low peak loads ensure comfort, also resilience, and then also reduce mechanical system size, which reduces upfront cost. Might be a lag here on the screen change. There we go. Okay, so the methodology here for these different space conditioning targets was essentially, it was an optimization process. So PHIUS optimized different building sizes and different occupant densities and essentially looked at different upgrade packages, specifically looking at passive measures, improving the envelope, improving the ventilation efficiency, improving the envelope R values, things like that. And what we did is we looked at where is that kind of sweet spot or that turning point where we're investing more upfront, but then the savings don't come to you. So you see this graph in the top left-hand corner, source energy savings increasing to the right along the bottom, and then the total cost of operation, which is your upfront cost, plus, so your upfront mortgage cost, so your annual mortgage, plus your utilities. Where does that go higher than your savings? Or where is that kind of turning point where you're diminishing returns, essentially, on your upfront investment? And so we did this kind of forced optimization, air sealing just to meet the PHIUS Plus target, so the 0.06, and then the window performance to ensure comfort. And then we let it do everything else on its own. So it chose these different packages, showed how much energy it saved, and plotted these points. And this is what it looks like here. So here's an example. This black curve, this black kind of solid line on the bottom of the curve is the optimal path. So this is where you're saving the most amount of energy for the least amount of total energy related costs. And what we do is we pick the minimum point on this, where you're spending the most overall, again, between operational energy and upfront cost, and saving the most energy. So probably right above that 45, right next to that circle is where you'd pick to stop investing in conservation measures. And I guess it's important to note that in this optimization, passive measures could compete with mechanical efficiencies. So you could, increase insulation or improve your window to compete with a higher performing heat pump or something like that. But passive measures did not compete with PV. And the reason we basically just had conservation measures, passive and active, compete with themselves rather than PV, because PV still itself, I guess the argument is PV can't heat your home. So PV can't replace all of these things. So even if PV got really, really, really cheap, there's still a core level of conservation and efficiency that should be met just to optimize the total building's performance. So in the bottom chart, you can see here kind of the benchmark building versus the optimized building on the right. And what passive building really does is it crushes the heating and cooling demands. So that red box, it can still, remove a lot of the need for the heating in the building, and sometimes remove the need for cooling. Sometimes it stays the same, depends on the building type. So again, we optimized these 5 different building types, different occupant densities. And what you get out of that is space conditioning targets for the building that vary based on both building size and occupant density. And the way we look at building size is the ratio of the envelope area to the floor area. So here's just showing 2 for Chicago here. The envelope area in the first is 2.5, which is maybe a smaller single family home. Whereas on the right, it's 1.1, which is maybe a townhouse. Townhouse, maybe 8,000 square feet, 4 in a row or something. So you can see there's different space conditioning criteria. And again, so this varies by climate, both this envelope area and then occupant density here. So if we took the same townhome building and put 500 square feet per person or 250 square feet per person, you get different targets for that. And these are all, again, based on this optimization, getting all the results and then extrapolating or interpolating rather, everything in between these study cases. Air tightness is the next main performance metric. It is required to have blower door testing, both pressurization and depressurization, and you must pass, so it's pass-fail. The main certification target is 0.06 CFM50 per square foot of envelope area. It's not volumetric, it's not in air changes per hour, it's per square foot of envelope. And again, this is based on the building durability rather than volumetric, which could lead to very different air leakage per square foot of building envelope when you get at different size buildings. So just for comparison, the 0.06 CFM50 here per square foot for maybe a 2,500 square foot residential single family home is roughly 1 ACH 50, roughly. It goes lower for larger buildings and higher for smaller buildings, or rather for buildings with more envelope area relative to floor area. And then you can test it at 75 pascals, and there's a higher limit there. And there is, I know this is mostly a residential webinar, but for buildings 5+ stories of non-combustible construction, there is a slightly higher air tightness target of 0.08 CFM50 per square foot. And that's again based on less risk of building durability. As air transfers through, Sam did talk about this, but as air transfers through a building assembly, it's more vulnerable to rot or mold or carrying moisture. It does help dry out, but it also carries moisture with it. And then the last kind of main pillar here is the on-site quality assurance. So again, this is built on the US recognized systems. We're trying to align everything here. So the Department of Energy Zero Energy Ready Home, EPA and R+. You get the HERS score for residential buildings. There's multiple site visits. It's all third party, ventilation balancing, commissioning, insulation inspection. And again, this is just providing assurance that the built product is what was actually planned. If something changed along the way and something got value engineered out at the end, you should know about it, you should adjust that, and you should expect the performance of the actual as-built product. Or keeping that third party there assures that things actually do go as planned if you do have something like a certification on the line. And Sam showed this, but this is just adding one more element here. So we had the IECC, Energy Star, Zero Energy Ready Home. We have PHIUS Plus, and then the one main difference here for PHIUS Plus Source Zero at the top is you have a source zero renewable energy system, and I'll talk about what that can look like. Okay, so the last main target here is the net source energy. So PHIUS has a few levels of the program. So there's PHIUS Core, PHIUS Plus 2018, and PHIUS Plus Source Zero. I am just talking about PHIUS Plus Source Zero, but I'll just briefly, PHIUS Core emphasizes a little bit more on-site conservation because the net source energy target can only be met on-site. So you can see kind of in the bottom here, it's just showing on-site PV. The PHIUS Plus 2018 or PHIUS Plus Source Zero targets can be met with both on-site and off-site. So a combination of both, one or the other, does not matter. Core is kind of setting that core level of conservation that should be met on-site, or that we believe is the stepping stone, or really the minimum level of efficiency, although it's a very high level of efficiency, the minimum level of efficiency you should hit before then going to renewables to bring that source energy factor down, or source energy use down. So the definition here, PHIUS Plus Source Zero is a building that must generate as much energy as it uses on an annual source energy basis. The target is zero. We use source zero because we have a target for source energy. That's not the only reason. I specified also the nuclear, it's better proxy for carbon, but we don't track any site energy. PHIUS's metric is always a net source energy target. So naturally, our zero target is also a net source zero target. But it does get a little confused at times. For an all-electric building, a site zero is also a source zero. And I'll show you that here for the offsets. So the sentence at the bottom here, 1 kilowatt hour of renewable energy generated offsets 2.8 at the source when the offset factor is 1. So the source energy factor for electricity in the US right now is 2.8. So if you generate 1 on site, we say you offset 2.8 at the source. So essentially, if you're all electric building, you reach site net zero the same time you reach source net zero. You're not generating 3 times more than you need on site. You're actually, it's the same offset. You're either offsetting 1 at the site or 2.8 at the source. So these are the renewables that are recognized as offsets. So you have the on-site photovoltaic arrays, you have directly owned off-site renewables, community renewable energy, virtual power purchase agreements, and then Green E certified renewable energy certificates, but those only have an offset factor of 0.2, which essentially means you have to purchase 5 to offset 1. Right now, all of the other options above it have an offset factor of 1. This may change in the future. The framework might change a little bit in 2021. I'm not exactly sure how, but potentially benefiting on site a little bit more than it does now. The certification, as I mentioned, is a 2-part certification. So there's pre-certification, a design review, making sure the building as designed passes specific performance targets in an energy model. And then there's the on-site quality assurance inspections and testing. And then truing up that as-built building with the pre-certified energy model. And the source zero certification is awarded based on modeled energy use. So at this time, there's no tracking of or monitoring of energy use to verify that it's net zero or source zero. And just to kind of end this off, source zero was introduced with PHIUS Plus 2015 standard, so about 4 years ago now. Since then, we've had 47 total projects pursue this. 14 of them are fully certified, 8 are pre-certified, and 25 more are in progress. And with our 2018 standard getting on the path, very much on the path to zero, we're seeing many, many more projects that just choose to go all the way to zero. So it's really, I don't have the year by year, but it's really significantly increasing and becoming a lot more common for everyone. And that, I believe, is my last slide there, Brett.